So number 5 here in your assignment, proving these here. I have a line here that shouldn't be there. Didn't get drug over. Okay. So again, we want to prove that tan squared equals secant theta plus 1 times secant theta minus 1. One of the tips that we talked about is performing indicated operations. If you have addition, subtraction, multiplication, that sort of thing. If you can simplify by performing those operations, it might be a good idea. Now secant is 1 over cosine, right? So we may want to consider that. I'm just going to move straight to this multiplication. And again, you can use your FOIL method, right? Distributing binomial times binomial. So what does that look like over here? That looks like secant squared theta minus secant theta plus secant theta minus 1. So when you multiply first terms, outside terms, inside terms, and last terms from the FOIL method, this is what you get. What do you see here? What should I do next? Yeah, secant. We have a negative secant theta and a positive secant theta, so those cancel right out.
Do we have to show that step in between?
Do you have to show this step in between?
Yeah.
So the stroking out of the secants here?
Well, because I know it's a difference in square.
Right. Yeah, you should show this step. Yeah, absolutely. Because remember, yeah, you don't. If you leave any steps undone, there's a chance that you might not get the full marks for the question. Because again, you know that we're going to have this at the end, right? So all the marks are from here to here, right? So yeah, you want to show every single step, yeah, when possible. So that would be an example where you would show that. So that you'd show, and again, you can use, for me, you can use arrows like this to show what you're doing to get this step. That's fine. You wouldn't have to use the arrows, but this step should be in there for full kind of good communication. Okay. So then you just rewrite here secant theta minus 1. And then from here to here, obviously, you're using an identity, right? So if you can show me that you've got here, this tan squared theta equals secant squared theta minus 1 from your Pythagorean identity, then you just write down, okay, that equals tan squared. That's enough communication, and there you have left side, right side. Okay, questions there? So just to look back here from our first section, Pythagorean identities, that comes from cos squared plus sine squared equals 1. So again, if you divide everything by cos squared, you get this right here. And so that's what you get. That's 1 plus tan squared equals secant squared, which, secant squared minus 1 would be tan squared. So remember, you can manipulate any of these Pythagorean identities. You can apply the properties of equality because they are identities to begin with, so you can rearrange them any way you want and use that as fact. Okay? Okay, so here's the next one. Why don't you give this one a try? It's very similar to the one we just did. Okay, so on this question, here's the identity. At this point right here, you can see that if you manipulate this, cosecant squared x minus 1 is going to equal cotan squared x. So this is the identity that you would use to say this transforms into cotan square x. Okay, so you can go from here to here because of this form of the Pythagorean identity. Okay, questions about that? No, you don't have to show the original identity. No, I was just showing you kind of where it came from. So this is sort of an aside. You can go from here to here if it lines up with your identity. Yeah. Okay.